Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, End-to-End Data Management on Kubernetes with MinIO and RedHat OpenShift, brought to you by RedHat Marketplace and MinIO. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's webinar is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars or containerjournals.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Ur Tigley, CTO, MinIO, and Daniel Valdivia, engineer, also at MinIO. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Thanks so much, Julio, for the introduction. Hi, everyone. This is Ur Tigley. As Julio mentioned, I'm the CTO at MinIO, and Daniel, my colleague, is going to be helping me throughout this session for questions and answers, as well as he's going to present you a demo of how MinIO works together with the RedHat OpenShift platform and our Kubernetes integration using our operator specifically. So today we're going to talk about end-to-end data management on Kubernetes using our software MinIO, which is a full storage stack that is S3 compatible, and how we have done the work to integrate it into Kubernetes platforms, specifically for Red Hat OpenShift in this session. We will talk about a little bit about the Kubernetes world and how it is important for the modern applications that are being written today, and object storage is becoming the de facto standard for these. We're going to talk a little bit about the work we've done for Kubernetes integration, specifically for Red Hat OpenShift. I'm going to ask Daniel to provide you the details around the demo and how MinIO look and feel from an integration perspective, and our operator and our UI. And then I'll take back the slide deck and our presentation and talk about the use cases that are mostly popular across the industries, as well as our customers and users that are deploying at large scales. First, I want to talk a little bit about the Kubernetes world, as well as the changing world of application development. So most of our, about 10 years ago or so, most of us are very familiar with the applications being a single entity, complex and slow update cycles, and they don't really scale well. It's a one-to-one database to front end type of a setup, and we've seen that approach failed in many instances because either the upgrade cycle was taking forever, it would take a couple of days to take the database down and upgrade the single app. It was really not easy to keep up, and operational support and IT infrastructure that's required was tremendously expensive and very laborious. It was taking many hours to keep these type of applications. With that, there has been a quick shift, especially with scalar companies that are using mostly for social media and other type of applications. They just wanted to go and design a small set of those classical IT infrastructures that is going to align with the application needs and have smaller services that are interconnected, that's going to provide the right outcome for their businesses. And hence the cloud native approach to application development became the de facto standard in today's world, because the microservices approach, cloud native approach, allowed people to write applications in isolation from each other, and having isolation reduced the failure domains, and that allowed for many more instances of it, and allowed for large scale. With that, a faster technology adoption became easier, and MinIO started right at the end of that or the beginning of that cycle, because object storage was, thanks to AWS S3's S3 service, as well as the protocol, allowed us and many other applications to be able to adapt to a different world of microservices, cloud native approach using APIs, as you can see on this simple representation picture. Why object storage is important for cloud-based applications and the new world of microservices and cloud native approach? Because object storage, like MinIO, is started from scratch for APIs, and it's RESTful APIs. It's API driven, easier for application developers to adopt and start using it immediately, just part of their application development. It doesn't have the POSIX legacy integration that's required. It can scale tremendously, and object storage such as MinIO can scale very easily from terabytes to exabytes, and it's infinite scale, it allowing us to be able to write an application that can run on the cloud, regardless if it's public cloud or an internal enterprise cloud, private cloud, or at the edge, doesn't matter, because everything is written in a way that can scale easily in a very simple manner. And efficiency and resiliency is also another factor that was important in the early days, because erasure coding, bit rot detection, which are the pretty much the components that are really integral to object storage, made it so much easier to store a lot of storage and have them in a very high performant manner, readily available. Data lakes, AI type of use cases, which I'm going to cover later in this presentation, they were really data hungry, and they needed this performance more from a throughput perspective. They weren't trying to do more transactional type of operations, and object storage that is across the clouds made sense for many applications, and many applications written for this new world. So that and Kubernetes kind of intersect at some point. The reason Kubernetes started to become popular is the same reason why cloud native object storage such as MinIO became popular across application development, because they were both solving and providing similar solutions to the same or similar problems. That is scale, that is multi-tenancy, and also ease of operation. You can have a Kubernetes environment, and that can isolate many different microservices and use cases, different departments, different control domains. As we mentioned, the failure domains can be isolated with using Kubernetes technologies, and same for object storage. If your storage goes hand in hand with your processing power, your processing platform and framework, it's easier for an application to grow and to be stable when it goes into the petabyte scale. With that said, MinIO started about 2014, 2015 timeframe, and we started with a clean sheet of paper. It was not the POSIX file system. It wasn't the distributed file system people were used to at the time. The background of MinIO engineers and the founders come from a distributed file system background. GlusterFS was one of their previous company, and they know the benefits as well as the huge minuses of having a POSIX-based file system in the new world, and they wanted to have a very simplified approach to solving data problems and storage problems. With that, MinIO came to existence, and it became the standard for any hybrid cloud, any multi-cloud environment from a data perspective, because of its easy installation, easy use, and simple approach to the architecture of providing a full stack, full enterprise features, and having the protection of data within. In the beginning, it was 40 or so megabytes. Later, it became a little bit larger, 60 megabytes of a binary or so. We were able to provide all of these, and high performance as well as Kubernetes native object store. We started with Kubernetes and containers early on. Therefore, in the industry as well as in the community, we became quite popular choice from a full stack persistent data choice for any Kubernetes environment. Hence, we started making sure that we are building integration to all popular flavors of Kubernetes. And today we are specifically talking about Red Hat OpenShift in this presentation. The reason why Kubernetes native object storage is getting associated with MinIO in the industry and in many use cases for large enterprises as well as application developers are some of the reasons I mentioned. Not having a POSIX background and back luggage that you need to carry into the new world of applications is quite important. Amazon S3 opened the world of S3 protocol as well. People look at S3 for two meanings. One is the S3 services, storage services Amazon provide, but more importantly, in application development, S3 is the default API for object storage, and MinIO is the leader in this. And any alternative of Amazon S3 services as a protocol that you want to have on-prem across different clouds, MinIO is the single choice there. We have focused on one thing and one thing only, and that is having S3 compatibility, and we are strictly consistent from inception, and that made us the only choice for people who are building their own infrastructure and cloud within their four walls. It can be within the country that they cannot send the data outside, or it can be within a company that they just have to keep their data on premises, and MinIO is the only choice for that. And also, some of the statistics here shows that both for containerized and Kubernetes type use cases, MinIO is dominant player, and it is quite popular. This is just a slide that shows the popularity of MinIO across. Probably we've been tracking since we started providing container-based MinIO packages, and we are up to 700 million now in terms of the Docker pools that we have seen and counted up to this point. So this is just showing the tremendous popularity of MinIO in the industry and our support from the community. Application developers download MinIO. Its ease of use allows them to just simply start using them in the early stages of their application development. And then when that application goes into production, they just build a large MinIO cluster and contact us from a commercial engagement, and we get deployed into larger environments that way. So this is our open source roots and support for the community, allowing developers to take MinIO and put it into their environments early on, is paying off tremendously in our popularity in the numbers that we've shown. So in terms of the perfect combination of OpenShift and MinIO is because Kubernetes, as I mentioned, is hand in hand, providing you the processing framework from a multi-tenancy, performance, as well as security. And MinIO is the data and storage component of that, and it can go hand in hand. If you look at some of the classical file system base or Hadoop base, like Hadoop has a component for storage called HDFS, which is going together with the processing, which is not the method of it's not the method of today, because it just doesn't work. The compute and storage growing together, it doesn't work in a cloud native environment. In my past, I had run large clusters of Hadoop, and having 1-2% CPU just for the space and disks that it provides was just not good use of resources. And it was just not good from a TCO perspective. So having Kubernetes, OpenShift, and having a very scalable and easy to use storage solution really turns into cost benefits in the long run. Software defined, MinIO being software only, allows you to put that into different environments and multiple instances easily. Appliance-based solutions in this world is coming to an end slowly, and they are just, it sounded like a great solution 10 years ago, but in this world of multi-cloud, multi-environment, it's just not really scaling. And having S3 as a protocol really helped MinIO to open to multiple use cases, as well, main use cases, as well as many applications, because thanks to Amazon, many third-party applications, whether it's query engines or databases, they all integrated into S3 protocol. And having that application catalog and marketplace allowed MinIO and OpenShift become the perfect combination to provide any type of infrastructure for a use case, whether it's AI or an edge use case or any type of a heavy performance use case that needs processing and data throughput at the same time. So with that whole story, we shifted about 2 years ago or so our focus from an engineering perspective to integrate into Kubernetes. And today we have integration to all sorts of flavors of Kubernetes. And specifically, we have the OpenShift, our operator is certified on OpenShift platform, and we have it in the marketplace today. You can go to either RedHat website or MinIO website. We put it down as a sticky note in the Q&A in the public chat today for you to click on it and take a look at it. We can easily run on top of any Kubernetes flavor across any environment, whether it's public cloud or private cloud. So operator came about when we needed a persistent storage stack that to work seamlessly within the native way of Kubernetes working. And that was using stateful sets, making persistent data a little bit different than the containers that is being managed by most of the Kubernetes deployments, because we were databases as well as persistent storage is a bit special from a Kubernetes perspective. So we developed our operator, MinIO operator, which Daniel is going to show you the UI that's sitting on top of the operator, and our operator that is responsible for deploying a scalable blocks of persistent storage or building blocks of persistent storage within Kubernetes environments. That's how we call it. It can be the algorithms and the logic that MinIO uses is the same, whether it's bare metal, VM, or containers. MinIO operator in Kubernetes setups allows us or allow the Kubernetes admins who doesn't know anything about storage to use our operator and set and configure building blocks of persistent storage easily from the get-go. It can be, you can provision world-class cloud-native storage from a couple of clicks using our UI, and our operator make sure that it gets deployed within the Kubernetes environment you use. It's great for multi-tenancy. It doesn't care about the infrastructure below it, hence the popularity of MinIO in public clouds using our operator. The main reason people choose our operator and MinIO software, the storage stack, is they can deploy it on-prem using OpenShift and using the same configuration and go to any of the public clouds and use the same methodology and use the same configuration. The MinIO storage will be readily available, sitting on top of whatever hardware that is provided to them from the public cloud vendors, and that provides no lock-in and seamless transition between on-prem and off-prem type of use cases, whether it's public cloud or any other data center that they are using. The abstraction is quite powerful, and it's quite popular nowadays from the use cases we see and the reasons why people choose MinIO. This is a high-level architecture of how MinIO sits into the whole OpenShift layers. As I mentioned, the hardware layer and the infrastructure doesn't matter whether it's public cloud or a local JBot with spinning disk or NVMe. It all gets abstracted through Kubernetes and OpenShift, and we just use persistent volumes that are presented to us and do the magic that we do in terms of resiliency and HA from a storage stack and storage protection, the mirroring, integration into security, IAM, all of that is included within the full stack MinIO object storage. And this is a sample of how a full stack of integration is being done using MinIO. We started early on with financial services customer base, and they were quite demanding in terms of identity management, the key management KMS that they use, and it needs to be integrated into the various one they each one use. So we have done a lot of integration early on, and that brought us today, a couple of years after. Now we have fully integrated into all of the common points of integration for monitoring, encryption, identity management. Whether in this picture we just have an example of Keycloak, we support any OIDC type of integration, but a lot of our large enterprises, they use Active Directory and LDAP, and we also support that as well. Some of our customers use HashiCorp, but some of them use Gemalto. We support all of these key management service integration, and we have written a lot of kind of supporting software that make their life easier in terms of key management. We have something called MinIO KES, which allows you to not go back to your KMS all the time and create heavy traffic against it. We try to use derivative keys in between because when you grow an object storage in the billions, you really don't want to hit your encryption key management server. And we have different solutions for Grafana dashboards for monitoring, or Prometheus scrubbing, and a lot of these integrations over the years made it possible for you to take MinIO software, use operator, deploy it, and then whatever other surrounding stack and software that you're using in your enterprise environment, we already have the integration figured out and have multiple flavors of that available. So that's at a high level what MinIO is, how we became very popular within the Kubernetes world because of our ease of use initially, and then our operator and our heavy investment in engineering investment in operator and integration into various flavors of Kubernetes, and we have came to a point where it is now a no-brainer because of the surrounding integration we have. With that said, I'm gonna let Daniel take over the controls of the screen, and he will show you a demonstration of our UI as well as the MinIO operator. And after Daniel finishes the brief demonstration, I will take back the slides and talk about a few of the common use cases that we see in the industry. Daniel?
Thanks, Ur. All right, let me share my screen. All right. So can everyone see my screen over there?
Yep.
Let me check on the chat. All right. So what I'm going to give you is a demo of the MinIO operator, right? So this is the same operator that you can get access through the RedHat marketplace. And pretty much you can also update at your own pace. And then we went to great lengths to simplify the management of MinIO via its operator, right? And reduce its complexity by a lot. But we didn't stop there. We wanted to also bring a nice user interface. For those who didn't want to be dealing with the YAMLs all the time, but then don't be fooled, like everything that I'm about to show you can also be achieved through YAMLs or CLI, right? Those are great ways to achieve automation. But sometimes you just want to, have a nice UI and see things for yourself, right? So you want to explore, you want to discover features, you want to understand how things are configured. So that's what I'm about to show you. So here, I like to show my demo by relying on a single sign-on, right? So this is where we mentioned we support multiple external identity providers. You can bring up Keycloak. I actually hop here throughout zero. And after logging in, I'm greeted by a list of tenants, right? So MinIO, the tenant is the analogy that we use to describe a MinIO deployment. And as you can see, I set up tenants of different capacities, right? So one is 1 terabyte, one is 2 terabyte. They have different usages. They can be upgraded at different times. So this is the unit of abstraction that we use, and they're also namespace. So we actually allow you to put your tenants on different namespaces. This gives you great control over security and network. And I think the best way to also understand a tenant is actually creating one. So I'm just going to go over here on the top right and hit create tenant. And then I get created by a set of steps where I can see, okay, I'll be placing a new tenant. Let's say this is a tenant where I'll be putting some big data for the EU West 1 region, right? So I'll just put some name over here. I'll select a namespace. And after selecting the namespace, the storage classes available to me will be listed. right? So we also respect resource quotas on these namespaces. And you can see all of the Kubernetes structures are actually being leveraged here. And now I can pick the storage class for the type of storage that I want. If I'm building a hot tier, right, perhaps I want to do NVMe drives for fast access. I can do also SSDs or hard disk drives, right? This is where the CSI driver can actually provision me whatever type of storage is available in the system, and that is exposed via storage class. So for a big data setup, let's go with my standard class. This is going to be backed up by hard disk drives. And then the next question is, okay, how big do you want this tenant to be? So this is where you could be, okay, perhaps we're going, like we're actually setting the big data store for this large setup. On my cluster, I don't have more than 4 nodes, so you're going to see an error. But let's say I go with 32 nodes and 106 drives per server, and I'll just be building something about 100 petabytes for this one setup, right? Something extremely large. And the idea of this user interface is that you can get an idea of what's going to happen, right? So if I'm provisioning something this large, you can see that choosing the erasure coding parity value, and erasure coding is how MinIO protects its data. Out of 100 petabytes of data that I'm about to provision, 50 petabytes will be usable. Now, this is still, you can argue that, okay, that's too much data being used for parity, right? So, but also this setup will allow me to lose half of my servers. Out of the 32 servers that I'm setting up, I can lose 16 and still in line. Yes?
Can you hit refresh? It's a little laggy here.
It's a little laggy. Which screen are you stuck at? Ah, I see.
Yeah, like I still see half the login with SSO thing.
Okay, so I'm going to stop sharing and reshare again. Let's try that. Thanks for bringing this up.
Thank you.
Okay, so how's that now?
Well, that's good. That's clear. Thank you.
Okay, so we're setting up something for US1, some namespace, storage class, standard. And then I was pointing out that if you set up something very large, right? So I was saying something like massive. I was pointing out that I can play with this and understand what's the SLA that I can provide, right? By the fact that I picked this erasure coding parity value, what does it mean? It means, half the capacity will be dedicated to keeping the data safe. And this also means that I can only tolerate half of my servers going down, right? So you can see it might not be reflecting, right? So can you guys see the screen, the circles on my screen? All right, so we're hitting some technical limitations. Let me quickly switch to backup systems. The problem remains, right?
Yes.
Matt?
Yes, it does.
Okay,
it's laggy, and then there are artifacts on the screen. It probably looks great where you
are. It looks great on my screen, but it seems like maybe it's my resolution. That's what I'm thinking. What if I decrease my resolution altogether?
Well, now I don't.
Maybe. Yeah. I'm gonna decrease my resolution. Let's see if this. Oh, this is too small, but this may be just right for this. Let's see. All right, here comes my screen again, and then we see everything. Yeah, from border to border. Perfect.
Oh yeah, and you drawing. Okay, let's go.
Oh, perfect. Okay, let's go. Yeah, seems like the screen resolution was probably too high for this webinar, so it's fine. So anyway, I was pointing out that for this 32 server setup, right? So I can lose half of my servers, right? That's a great way to understand the SLA for whatever I'm provisioning. So I could say, well, this is a big data setup. Of course, we rather have more data than resiliency. So maybe I can go down to EC4. And now I can see that for this EC4 value, I out of the 100 petabytes of raw capacity, I get 75 of usable capacity, and I can still tolerate 8 servers failing, right? This is a great way for me to understand the SLA that I can provision to different, let's say I'm using different tenants for different business units or different customers altogether, right? Or different teams. I can understand what is the type of resiliency that I'm about to provide them. And perhaps for some production workloads, you actually want high resiliency. And for some archival use cases, perhaps you want low resiliency, right? So you really like, this is an archival tenant. I really don't mind if there's some downtime, or I can tolerate as low as 2 servers going down, like if you were going with something smaller, right? So that's the idea of this screen. Now I'll go back to something that fits my demo environment, but you get the idea here. And other things you can configure is, of course, you can configure exposing the services right off to the outside, right? So this will leverage Kubernetes load balancer type services. So you can configure the images that you want to use, whether you want to bring a private Docker registry. You can also configure that. You can configure pod placement. This is very nice, right? So now we see customers building very large OpenShift Kubernetes clusters, and then they want to mix all the workloads, but then they perhaps want to select only a certain type of nodes by architecture or some labels. They can do that here. Identity providers, right? As mentioned before, MinIO comes with a built-in identity provider, but of course, I can also configure OpenID-based authentication. This is where Keygle comes into place to provide single sign-on type of solutions, or Active Directory LDAP, right? So if your company is using LDAP and you want to configure it, now you can actually configure it here and enforce it at the tenant level. You can also bring your own certificates, right? So by default, we generate all the certificates to encrypt the communication inside the Kubernetes cluster, usually in certificate signing request. And you can also terminate TLS at MinIO, so you can bring the certificates that you are going to be using, right? So this is pretty straightforward. Once you have established a secure communication channel, you can talk about encryption, right? And this is where you can come and configure encryption for this one tenant, right? So like if this is a tenant where encryption will be handled, this is where we support, for example, HashiCorp Vault or AWS KMS or Gemalto. You can pick the type of KMS that you want to use as the back. We support the most popular ones, but any KMIPS compliant KMS will also be fine. Of course, now this from the beginning was a pretty simple setup, right? Just being asked, okay, what's the name of the tenant and how big do I want my tenant? After that, I can just hit create, and that's it. My tenant now it's getting provision, right? So now everything that we were setting up right now, it's the operator is actually taking the lead and creating all the resources, right? So all the pods, stateful sets, PVCs, configuration, etc. And you can actually see the YAML that's actually generated, right? So if you're more comfortable with YAML, you can still, grab this as an example.
Sorry to interrupt you again, but can you try to refresh to the other screen? It's just happening again for me. Is that the same for you, Matt, and others?
It is. I don't know. I don't know what we can do. I assure you, in the audience, this is a presentation thing, not a MinIO.
Yeah.
Yeah. So you can.
If you were to go to another screen and come back, it refreshes like exactly what you did before you got out. If you were to go into a different tab and come back, it kind of refreshes. Let's try it one more time. Yeah.
Okay. Okay, that's good to know.
Yeah. It's building out.
It's not like a codec thing, right?
Yeah.
Yeah. Okay. Yeah, that makes sense.
So click the storage and tenants and back and forth, and it refreshes and rebuilds the screen. So it cleans it up a bit. But if you're within the same screen and going to various places, like this, it's like a screen in a screen. It doesn't rebuild it well.
Yes. Yeah, this is the risk of live demos, right? Just
Now we can see the YAML. So if you want to talk about the YAML here, we can see.
You can see it entirely.
Yeah.
Okay, perfect. All right. So I was talking about the YAML, right? I can even see it glitching as I scroll.
Yeah, just try not to move too much and just go from one to another. Because if you start cruising around, then it cannot keep up with you.
Okay. So I was showing you guys the YAML, right? So if you wanted to use this as a reference, and then you check this into your repository. But then the idea here is that you can, I think the problem came back again. Okay. Did the problem went away?
It's good now.
Yeah.
Just try to stick to one page and explain, and then go to another, slower in the movements of the mouse. That's all.
Yeah, it's a tough one. It's a tough one. Okay, so I was telling you about provisioning of the tenant. So let's try to go into a single tenant screen. See if that doesn't load. I'm gonna do the window trick. Okay, that loaded. So here I see like the state of my tenant. I get an idea of its usage, its endpoints to be consumed right away, the version of MinIO. I can immediately hop into the tenant and start managing it. So you get the idea of what this technology is bringing to the table, right? This user interface is letting you manage these tenants in a very seamless way. So you get the same experience that you get on the public cloud for the private cloud, right? So it's very easy to provision clusters. I mean, if I could click freely, I will show you the metrics and show you our Prometheus integrations right off the bat. And you can expect from all these tabs that I'm avoiding clicking right now, the things you can configure after the fact, right? If you need to rotate certificates, you can just go into the security tab and rotate them, pools, etc. So to try to keep things not so glitchy, I'm gonna go next to the MinIO console to showcase the Prometheus integration that we have. So, and then that glitched. So we do the swap, and that seems to have fixed it. And all right, so you can see after I logged into the management console, so this is a different user interface from what I was showing you earlier. I was showing you earlier a user interface for managing MinIO deployments on top of Kubernetes. But then once those deployments come online, and now you're ready to start putting data in them, right? You can start putting anything that you want. We also ship a user interface for MinIO where you can actually see what's going on, right? I logged in here and I'm greeted by a set of metrics, right? This is pulling them straight from Prometheus. And this showcases also a Prometheus integration. All of these metrics are also available as Grafana dashboards. And I can actually use this interface to manage things in my system, right? So for example, if I were to look at my buckets, so I can see the list of buckets that I have on the system, right? I can then browse its contents, see its versioning. If I were to create a new bucket, I can explore its features. It's a very complicated demo when I cannot click things as often. I'm improvising here, guys. All right, so if I can create buckets, discover the features. For example, we support versioning. So this is pretty useful if, okay, we got the glitch again. Versioning is pretty useful if you want to, store multiple versions of the same object on the same location. Locking, right? If you want to disallow objects being deleted, we support quotas. If you want to build a multi-user system where you actually are sharing the access to the system via buckets, right? You can just restrict them and tell them, okay, I'm going to give you a bucket with 1 terabyte capacity. If you run out of space, come back, I'll give you more. But overall, you get the idea here, right? So that we're managing MinIO on top of OpenShift. It's something that through the operator is quite simple. And on top of that, we build this nice user interface for you to both administer the tenant CRDs that we have and also discover the features. And moreover, once the tenants come online, you can also access them via this user interface or to their respective individual user interfaces. You can delegate this access, right? You can pretty much go to your object storage administrators or the team who actually requested the space and tell them, okay, here's a user interface, go manage your own object storage, make your own buckets, create your own policies and users. It's pretty straightforward in that sense. All right, so I think I'm going to hand it over to you, Ur, at this point, because everything else on the rest of the demo is pretty much clicking around, and I think this glitchy bug is not going to let us do that.
No problem, Daniel. And the idea is everybody is welcome to go to the website in the sticky note and download the MinIO operator, and you can try it very easily on your own as well. So we just wanted to give you guys a flavor of how it looks like and what are the full pledge of things that you can do in an enterprise environment when it's a multi-tenant environment. So I want to just talk about let me share my screen back, and I want to spend maybe 5 more minutes on some of the use cases that are most popular amongst our customers, and then we'll open it up for Q&A, and that will be the right section where we can go a deeper dive into some of the technical aspects of what we are presenting here. And if you have any questions regarding to that, we can leave enough time for that discussion. So one of the most important use cases or methods people like to use MinIO in an OpenShift environment, in Kubernetes in general, is the advantage that it provides from a multi-tenancy architecture perspective. MinIO, together with Kubernetes and OpenShift, allows you to orchestrate a true multi-tenancy environment within your own enterprise. So cloud providers giving this out of the box from the get-go, but when it comes to on-prem, as Daniel said, having that cloud provider experience, it's not that straightforward. So having a technology component that is, the storage and processing, as well as network that is multi-tenant in its own architecture, allows you to get there a lot quickly. So this allows you to have a cloud-like web scale deployment within your own environment. And when you really do the multi-tenancy correctly, integrating with the right IAM, right security in terms of encryption, both at rest as well as in flight, it allows you to create a truly scalable multi-tenant environment. You can provide one tenant for and its own isolated namespace with its storage for one department, a set of developers, or one application, and then another namespace and a tenant for another application. This allows for quite large scalability within your own environment and provides efficiencies. And it is quite easy to manage and efficient, and it translates into cost savings from a large scale deployment. In terms of the other aspect that is also as important as multi-tenancy, they are kind of hand in glove, they go together, is self-service on Kubernetes. Most of the large enterprises that are deploying MinIO together with OpenShift, they are looking for a sense of self-service for a developer, for a group, for a set of application owners to be able to use a portion of the resources, portion of the infrastructure. And using MinIO operator together with console and all the integration points that we talked about, whatever the infrastructure is, whether it's NVMe, bunch of HDDs that you have, and that you slice them for different use cases, you can easily have a self-service Kubernetes environment. And that allows you to simply segregate different types of infrastructure and provide an isolated environment for your applications and users. And that's quite important when it comes to different customers approaching MinIO for their use cases. This slide just talks about, in general, some of the use cases that our customers uses MinIO software for. And one of the main ones is big data and machine learning environments, whether it's query engines, AI training, or any type of big data that requires throughput and high performance storage. MinIO is there. And having this together with Kubernetes, we have a large financial institution that I've been working closely for the last 6 months. They built all of their query environment and big data. They replaced their big data lake with MinIO storage and using Kubernetes to build a full stack with network to IAM to KMS integration. They built everything using Kubernetes and MinIO at the center of that data lake. The old school of using, as I mentioned, Hadoop-based data lakes and data architectures are going away. And a lot of our customers use MinIO, the efficiencies that's provided by object storage and cloud native object storage with reference to HDFS is quite quite clear. The advantages are quite clear, so they are all coming to MinIO and replacing those legacy environments for high performance needs for their data lakes and data infrastructures. And apart from that, we mentioned this lightly, but there are a few new generation of use cases where the applications are developed for cloud, but they need to run on various environments and endpoints. And they also use MinIO because of its lightweight nature. And we have done a lot of endpoint or edge use cases where whether it's autonomous driving, where they needed to do certain processing and they need a certain amount of storage, but they need to take that storage and consolidate it on a main data center, or some kind of a edge use case where they just need to keep and rotate the data at the edge and not even worry about syncing it back. They just need to go together with processing and they send the summaries or high-level information back to a centralized location. With that said, this slide goes through some of the popular names and tools and languages that uses or recommends MinIO as the native S3 storage that goes right out of the box. Like TensorFlow for many years has been putting on their website to use MinIO as an alternative to what AWS S3 integration is. Spark use case is one of the most popular use cases. This customer that I mentioned that are using us for processing use Spark in some cases as well. Many of other customers use Spark and S3A in the Spark community and Hadoop community with Hive and other integration. S3A allows you to integrate into the whole ecosystem, and using an object storage like MinIO becomes a quite straightforward migration. They don't really have to worry about changing any of the only thing that they change is a config file where instead of pointing out to a data store of HDFS, they point to S3 while changing the S3A configuration. Kubeflow is another tool that is quite popular that allows for S3 integration, and a lot of people use MinIO for their backend storage for Kubeflow. So with all of that said, a few key points that I want to summarize and open up for questions, and we can discuss some of the technical details if there are any questions regarding to those. OpenShift and MinIO together is truly providing you an alternative to what you can do in cloud native environments using a public cloud storage solution together with processing. So if you were, for whatever reason, there are many reasons people use today to create an equivalent environment on-prem that uses a Kubernetes flavor, a storage, and a query engine, for example, for the data lake use case I mentioned, and they need a cloud native stack. OpenShift and MinIO is there to cover all of the persistent storage needs and processing framework needs, and you don't really have to worry about locking into a public cloud provider or any type of an appliance setup in the traditional IT way of solving problems. All software, all using commodity components, you can create a cloud native infrastructure easily. That's takeaway point number one. The other part is why MinIO is so popular within the community as well as in our large enterprise deployments and the IT as well as development communities within those companies that use MinIO. It's this super simplicity that comes with MinIO. MinIO, if you go to our website and download the core binary, it's only one command line pointing out to if it's a distributed mode, 4 different nodes or 4 different directories if you're doing in a local test environment, and your S3 compatible storage stack starts running. And if you take that simplicity and apply that into a Kubernetes-based production environment, the simplicity allows you to have an operational easiness, and that ease of operation translates into cost savings and a lower TCO. It's simple as that, and that's why it's a very very obvious choice for large enterprises who are trying to cut costs and not to go into a public cloud type of a solution for various reasons. And the other part is MinIO has not only spent all that time developing the operator, but we also invested tremendously into our integration work, whether it's with direct CSI, which is the software component that within a Kubernetes World allows you to take raw disks and allows you to provide them as PVs to your Kubernetes environment, whether for MinIO users or for somebody else, or databases or other applications, or the integration work we've done with load balancers that we have written called Sidekick, that is for high performance applications. We allow you to take the MinIO software stack with all these other components that is simply coming together with the same software and same commercial engagement with MinIO. Make your life, all of these pieces make your life easier when building a large enterprise class integration using Kubernetes, using OpenShift and MinIO as your persistent storage solution. So with that said, I will stop here. We have about 10 minutes or so and want to open it up for questions, and I'll ask Julio for help in terms of getting through the questions, and Daniel and I will be happy to answer them.
Yes, we do have a couple of questions here. If you do have a question, please head on over to the Q&A section, type in your question, and we'll read it read it for the speakers. First question: Are there limits to the number of versions you can have for an object in MinIO or the OpenShift integration?
I'll try to answer that, and Daniel, if you can help me. In terms of the versions for the object, I think is the question, right? The objects within
it seems like,
system?
yeah.
Yeah, okay. So there is, I don't believe there is a limit on the number of objects. S3 API is an atomic API from the get-go. So versioning in S3 protocol and MinIO is essentially basically a header or a link that provides a link to the previous version of the object, because that's part of the S3 API anyways. From a versioning perspective, each transaction is atomic. If you were to copy paste, it will create a different object. And we have versioning within MinIO, and we try to there are certain applications that goes tremendously high in the number of applications. It just creates a lot of noise and extra processing. So we try to avoid our users not to go into maybe thousands or 10,000s of versions are probably fine. But if they go higher than that, we try to talk to them and understand why they need to go that far, and if there is other ways of solving the same problem. Because if you go above that 10,000 range of versions, then there may be some other way of solving that problem rather than using object storage. Daniel, am I right on that description? You may know a little bit more on
yeah, no, that is absolutely correct. Yes.
Yep. Yeah, so we don't really limit on the versioning. Like similar things, we don't have a limit on the number of buckets within MinIO, whereas AWS S3 and AWS and some other public providers has a limit on the number of buckets because of the DNS tricks and things that they do. We don't have those restrictions or the same setup that they do, so we don't really have those limits, and same goes for versioning. But of course, saying something doesn't have a limit doesn't mean that you should do it, and there are certain impacts onto the resources that you use. So we try to discuss with our customers on those details, but theoretically speaking, from a code perspective, there is no limitation in that area.
Okay, great. Next question: How does MinIO support multi-latency on OpenShift?
It's multi-tenancy. That is the part where I was trying to show that the MinIO operator allows you to set up different tenants or different MinIO deployments with different configurations. And part of the demo that I skipped were kind of like setting tiering, for example, right? Where I could set up a tenant with fast NVMe and configure tiering after 30, 60 days to move the data into another tenant that's actually backed up by solid state drives or hard disk drives. This is kind of like a warmer tier. And you could even configure tiering down to a cloud provider. So let's say data that's aging, 1-year-old data, 2-year-old data, you want to push it to a cloud provider to cut cost. You can also configure that on MinIO. And this is because the configuration of every tenant can be different from one another, right? So you could, maybe you don't have that much NVMe, and you have a tenant that's your hot tier. It's very fast, it's snappy, but it's not very deep. So, but then you build it with NVMe, and then after 15 days, you tier the data into solid state drives. Now, this is transparent to your end user, right? That's part of our hybrid cloud strategy. But going back to the multi-tenancy question, the advantage of the operator is pretty much that, right? So every tenant is isolated from one another completely, even including by namespace. They can be upgraded at different times. So you can actually have a production tenant, two separate production tenants, and have different update windows for them, right? Expand them at different times, etc. So that's how we actually handle multi-tenancy.
Excellent. Thank you. Okay, I don't see any other questions. For now, I will remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you'll be able to watch it again. We will be sending an email link to access webinar on demand, and you can also find it on devops.com. Just look in the on demand section and it should be there. I did mention at the beginning that we were doing a drawing for 4 $25 Amazon gift cards. So our first winner today is Jason O. Congratulations, Jason. Our second winner is Josue B. Our third winner is Michael L. And our final winner is Jose G. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. If you don't see it there, please check your spam folder. Ur and Daniel, thank you so much for taking the time to put this presentation together and, for an hour of your time. I apologize for the technical difficulties, Daniel, but it seems like you worked through it.
Thank you. Yeah, I'm not sure if I should be blaming Firefox or my Mac. So
Thanks, Julio. Thanks for the opportunity. And for the audience, please go to the link that we provided, and you should be able to download the software there and take a look at it yourselves, and it will be quite easy.
Yeah. And you can also, hit us on GitHub, right? If you have any questions, or join our community on Slack. If you like, that's how we hang out with all the community and ask any questions that you may have, right? So, or you can also follow us on Twitter and ask over there.
Excellent. Of course. Yes. Thank you to the audience for their time and engagement. This is Julio Godinez signing off until next time. Stay safe, everyone.